Alright, so we're going to have a final discussion on lesson 4, which we worked on last week. At the conclusion of class, we had completed all of page 1, and you were asked to finish the rest of the activity from where we left off in problem number, or page 2. So I'm going to start with page 2 and then go through the rest of the handout. So whatever problems that you completed incorrectly, please go through your handout and make any corrections. So let's start with the table for this activity. So this is their table, as we talked about last week, that there were some minor differences between the table we established and the company's, the textbook company's table. The biggest error was the last entry for the 80 degrees opposite leg divided by adjacent leg. We came up with 5.668 instead of 5.671. So we marked that one out on the table when I displayed it, and I asked you to make sure you have that answer instead of 5.671. Again, if your table is incorrect, I ask you to fix it, and there may be a slight difference in our answers compared to the company's answers by 1,000. For example, for 20 degrees, adjacent leg divided by hypotenuse, we came up with 0.939 to 9.940. So I ask you if there was a 1,000th of a difference between our answer and the textbook company's answer, that next to the answer in parentheses write their answer down, because again they may be asking you questions using these answers instead of the one that we had slightly off by 1,000, and so I want to make sure that if we have a problem where they're using, let's say, 0.940 for 20 degrees instead of 0.939, that we at least have their answers also available in our table. So one of the things you were asked to do was to come up with a way of determining some patterns here. And so, for example, if in the problem it asks you look at a 20-degree row and a 70-degree row, and to see what kind of things that were the same, what were different. And so hopefully you notice that under the 20 degree, that the adjacent divided by hypotenuse, which is 0.940, and under 70 degree, that same answer showed up under the opposite leg divided by hypotenuse. So and as well as the 0.342 in the 20 degree, the second column ends up being the first column answer in the 70 degree row. So hopefully you notice that the two numbers are switching places, and that doesn't only happen in the 20 and the 70, but it also happens in the 10 and the 80, the 30 and the 60, and the 40 and the 50. So the relationship between that pair of angles, 20 and 70, as well as the 10, 80, 30, 60, and 40, 50, is that these two angles add up to 90 degrees, or complementary. So going back to our table, they're asking you to come up with the 35-degree answer. And if you look at the two angles here, they actually do add up to 90 degrees. So like the 2070 and the other examples, the 35-degree answer, the first answer, would be 0.819, since that's the second answer in the 55, and the second answer in the 35 would be 0.574. So again, those two answers are switching places. What we don't have is generally is a rule for the last column. So what I ask you to do is to consider letting this be column A, this be column B in the big table above, and then this column C. And is there a way of finding the C answer since the rule we're using is adjacent, opposite divided by adjacent, is your way of using the A and the B answer to come up with the C answer, since the first two columns use an opposite and adjacent way with no hypotenuse in that final column. So you have some options here. So you have A plus B, if I want to add them, if I reverse A and B, like 3 plus 4 and 4 plus 3, it's the same answer. What if I subtract them? In subtraction, they aren't the same answers. So like 3 minus 5 and 5 minus 3 are different answers. We multiply them. And like A times B and B times A, it's the same answer. Like 3 times 5 and 5 times 3. Or do we divide them? In the division, we do get different answers. So 1 divided by 2 and 2 divided by 1 are not the same answer. So if you've not explored this last column, see if there's a way of using the table that we created back here earlier. Is there a way of using the answers in the first two columns to come up with the answer in the third column? Please understand that the answer in the third column, these are all estimates. So you may not get exactly 0.176, but hopefully you get something like 0.176 and then some digits after that, or 0.1765, and maybe it comes like 88.3 after that, so it rounds up to 0.176. So just keep that in mind that these may not be exact, but hopefully in terms of the rounding process, we would get these answers. So if you've not explored that, go ahead and take a moment to see how you would take the first two answers and come up with the third answer. And when you come up with a conclusion, which method will work, please turn the video back on and we'll continue with this discussion. If you already have it, then continue the video on, because I'm going to talk about that pattern. So hopefully you found, after some investigation, that if you take the second answer, which is 0.174, and you divide it by the first answer, that we're going to get an answer that's very, very close to 0.176. So in this case, I got 0.176. If I take the third answer, which is the 0.500, and I divide that by the first answer of 0.866, we end up with approximately 0.5773. So again, we're very, very close. And we'll do one more where I'm going to go down to the 60, since these two add up to 90. If I take the second answer of 0.866 and divide that by 0.5, and we end up with 1.732. So we're going to actually the answer they have in the table. So this is actually a division, is our way of getting to the last answer. So if I take the second answer divided by the first answer, I will end up with the final column. So if I take 0.819 divided by 0.574, I should get approximately 1.428. And if I take 0.574 divided by the 0.819, I should get the first answer. It's an approximation of it. So 0.514 divided by 0.819 gives me about 0.628. Problem 9, they're asking you to make a decision about what kind of triangle is going to give me like the 0.839 if I'm using the first column. So let's look at problem number 8. Since 0.839 is a little bit larger than 35 degrees, so I'm hoping the answer is going to be somewhere right around, between 35 and 50 degrees. So let's go back to your answer. So I'm looking for 0.839, and actually for the first column, the answers here are going up. So 35 degrees was at 0.819. So I'm looking for 0.839. So that means that the answer is somewhere between 30 and 35 degrees. And again, this is an approximation, but they're asking you to come up with what you think is happening here. So for 0.839 in that first column, that means that the slope angle here, and we'll call this theta, that theta is going to be somewhere between 30 degrees and 35 degrees. Exactly what it is at this point, we don't know, but it's somewhere between that. And so it might be 32, 33 degrees, but again, somewhere between 30 and 35. All right, so starting with problem 10, they're being asked to come up with the angle of incline. It's also an angle of inclination. So we're looking for what is the angle at measurement at angle B. So this angle here at B, if I would shade the two sides that make that angle, the 250 would become the opposite side. BC is the hypotenuse, and AB is the adjacent side. So in this problem, we're looking at taking, in terms of table, we're looking at taking the opposite side divided by the adjacent side, which is the last column. We're going to be looking in that column to try to figure out the approximate angle that's going up, because we're not using the hypotenuse at all. So one of the things we talked about last Friday is that this table, these three rules, is kind of our introduction into trigonometry. And these three rules actually are going to begin that discussion today, is going to provide us a way to come up with mid-scene angle measurements if we know enough about the sides, or if I have a side angle and the diagram theorem doesn't work for this right triangle, then we have another way of finding that missing information. So going back to this problem here, if I take the opposite side divided by the adjacent side, we can come up with an approximate answer here. So 250 divided by 1,000 means I'm looking for somewhere in my table where I think the angle is going to be about 0.250. So if I go back to our table, look for 0.250. So 0.250 is somewhere in here. So it's going to be somewhere between 10 and 20 degrees. So again, it's an approximation at this point. So I ask you to estimate it. So the estimated incline here, again, it's going to be kind of an estimate here, but it's going to be somewhere around 15 degrees. That 2.250, somewhere between those two answers. All right, so I'm going to do one more, and then we're going to move on to the next lesson. So the rest of the handout is not finished. You need to complete it. Here, we're looking at the 20-degree angle answers in the table, and we're going to try to use those numbers of those answers to kind of come up with the answer to length AB. I went ahead and shaded the 20-degree angle, so it means the AC is the opposite side, and the hypotenuse is the 8.5, and the adjacent side is AB. We're going to mark X. And so basically, there's a relationship between these two sides based on 20-degree angle. So if I go back to our table, on 20-degree angle between adjacent side and hypotenuse, that's 0.940, or we get 0.939. So the number here is 0.939. And what you have to decide is, do I multiply by or do I divide by? It's very similar to what we did with the 30 to 69 triangle. In this case here, we're going to We want a smaller answer, the adjacent side is smaller, so we're going to take 8.5 times 0.939 to get the length of the adjacent side.